So Dalton's theory, concept. So on the basis of the last chemical combination, John Dalton proposed one atomic theory. This is I explained. The main postulates, here main postulates, all matter which is made up of tiny particles called as atoms. I explained this. All matter which is made up of tiny particles. Tiny means small particles, very very small, uncuttable particles, indivisible particles, tiny particles. These are called atoms. Atoms are indivisible particles which cannot be neither be created nor, which cannot be created. That means neither be created nor be destroyed in a chemical reaction. So this is the second point. I explained this part. Next, atoms of given element, identical mass and size and the properties, chemical properties also same. This point also explained with the example. Next one, atoms of different elements have different mass and size and the chemical properties also same. Right. Atoms combine in the ratio small whole number and to form compound. So now I told this example, CO2 comma H2O. So here atoms combine in the ratio small whole number. So CO2, how many atoms are there? 3 atoms, carbon and oxygens 2, carbon 1. H2 also 3 atoms are combined, 2 hydrogens, 1 oxygen. So this is about the 5th point. The relative number and the kinds of atoms constant in a given compound. Yes, those are constant only. In a compound CO2 it is a 3. Every compound, every molecules are having same constant. Dalton's atomic theory was based on the laws of chemical combination laws. So one is law of conservation of mass, another one is law of definite proportions. So let us see that. 7th point, atoms of same elements combine more than one. Suppose I am taking here H2 plus O2 gives rise to H2O. Different elements combine to form 2 products. One is H2O product. Here H2 plus O2, H2 plus half O2 I will take. Then here how this is H2O2, hydrogen peroxide. So here different elements, hydrogen and oxygen combined form different products, but the moles ratio is different. Here H2O, in order to form H2O, here 2 moles of oxygen and 2 moles of water will form 2 oxygens only. Here 2 oxygens, so bans this reaction. But here what is the product? Water. Here what is the product? H2O2. This is hydrogen peroxide. Hydrogen peroxide. So how many products are formed? 2 products are formed. What is the meaning of this? Atoms of same element combined in more than one ratio form and more than one compound, more than one ratio. For example, hydrogen combines with oxygen to form water and hydrogen peroxide. This is water, this is hydrogen peroxide. Hydrogen peroxide. 2 atoms of hydrogen combined with the 2 atoms of oxygen in order to form hydrogen peroxide. See once here, this is only answer, H2O and H2O2. Okay, Nama? Here, how many atoms are combined? 2 atoms and 1 atom of oxygen, 2 atoms of hydrogen. Then H2O will form. Okay, this is about the Dalton's theory. So here conclusion given. The postulates of Dalton's atomic theory, the atoms are neither be created nor destroyed. Then the result is called as law of conservation of mass. This is important. Law of conservation of mass means what? Atoms are indivisible particles. These are neither be created nor be destroyed. Neither be created nor be destroyed. So that is called as law of conservation of mass. Dalton's atomic theory, the element consists of atom having fixed mass. This is the law of definite proportions. The element consists of atom having fixed mass. The element is the substance. Element is a substance. H2 fixed mass 2 grams. O2 32 grams. Okay, not only element and also compound also. Any substance. Compound means what? CO2. So 12 is to 32. 3 is to 8 ratio. Fixed ratio by mass. And the number and the kinds of atom in a given compound is also fixed. So that is called as law of constant proportions. If you take element or if you take compound, that is having fixed ratio by mass. That is having fixed ratio by mass. This is about the Dalton's atomic theory. So based on the two laws. One is law of conservation of mass, another one is law of definite proportions. ఇప్పుడు దాకా నేను ఏం చెప్పానంటే లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ మాస్, లా ఆఫ్ డెఫినెట్ ప్రపోర్షన్స్, ఈ రెండు లాస్ని ఆధారంగా చేసుకొని డాల్టన్ అనే సైంటిస్ట్ ఒక థీరంని ప్రపోజ్ చేశాడు. ఆ థీరం ఏంటంటే డాల్టన్స్ అటామిక్ థియరీ. డాల్టన్స్ అటామిక్ థియరీ. సో దిస్ ఈజ్ అబౌట్ ది డాల్టన్స్ అటామిక్ థియరీ postulates. Let's go to the next topic. Let us see the drawbacks of Dalton's atomic theory. Drawbacks of Dalton's atomic theory. What are the drawbacks of Dalton atomic theory? According to the Dalton's atomic theory, atoms are indivisible particles. Atoms are indivisible particles. There is no other particle after the atom. ఇక డాల్టన్ ఏం చెప్పాడంటే మ్యాటర్లో అల్టిమేట్ పార్టికల్, ఇంకా ఆటమే అల్టిమేట్ పార్టికల్, దాని తర్వాత ఇంకే పార్టికల్ లేదు అని చెప్పేశాడు అనమాట. ఎవరు? డాల్టన్. కానీ తర్వాత జే థామ్సన్, రోదర్ఫోర్డ్, గోల్డ్స్టైన్ ఈ సైంటిస్టులు ఏం చేశారంటే ఇంకా వేరే పార్టికల్స్ కూడా ఉంటాయి దేంట్లో, ఆటంలో. సో కానీ డాల్టన్ చెప్పింది ఏంటంటే ఆటమే అల్టిమేట్ పార్టికల్, ఇంకా ఆటం తర్వాత ఏ పార్టికల్ లేదు అని డాల్టన్ చెప్పాడు. అయితే ఇక్కడే ఉంచండి. డాల్టన్ అటామిక్స్ థియరీ, ఆటమ్స్ ఆర్ థాట్ టు బి ఏ ఇన్విజిబుల్ పార్టికల్ బట్ ఇట్ ఈస్ నౌ నోన్ ఆటమ్స్ కెన్ బి ఫర్దర్ డివైడెడ్ ఇంటూ, దిస్ ఈజ్ ఇంపార్టెంట్, ఫర్దర్ డివైడెడ్ ఇంటూ smaller particles. Those are electrons, protons, neutrons. So atom is divided into other particles. Electrons, protons, neutrons are there. ఆటంలో ఎలక్ట్రాన్స్ ఉంటాయంటే, ప్రోటాన్స్ ఉంటాయంటే, న్యూట్రాన్స్ ఉంటాయి. సో మరి డాల్టన్ చెప్పింది ఏంది? ఆటం అనేది అల్టిమేట్ పార్టికల్, తర్వాత ఇంకే పార్టికల్ లేదని చెప్పాడు అనమాట. ఓకేనా చిల్డ్రన్? ఎలక్ట్రాన్స్ తర్వాత సైంటిస్టులు ఎక్స్ప్లెయిన్ చేసింది ఏంటంటే ఆటంలో కూడా ఎలక్ట్రాన్స్ ఉంటాయి, ప్రోటాన్స్ ఉంటాయి, న్యూట్రాన్స్ ఉంటాయి అని చెప్పారు అనమాట. సో అది ఒక డ్రాబ్యాక్ అనమాట. సో ఫస్ట్ పాయింట్ డ్రాబ్యాక్. సెకండ్ వన్, డాల్టన్ అటామిక్స్ థియరీ ఈజ్ సెడ్ టు బి ఆల్ ద atoms of the element have exactly the same mass. Suppose I will take the isotopes. So according to this point, atoms of the element exactly same mass. What is the meaning of this? I will take one example. Isotopes, any isotopes you can take, no problem. Isotopes of I will take carbon. Isotopes of carbon, C612, C613, C614. These are the isotopes of carbon. What is the meaning of this? Isotope means what? Atoms are atoms of the same element which are having atomic number same, but different mass numbers. Okay, chemical properties same, physical properties different. That is called as isotopes. Okay nama? Sorry, let us see here. Here the mass is same or different? Different. But here what is saying? Atoms of the element have exactly same mass ఉండాలి అంటున్నాడు. కానీ ఈ ఐసోటోప్స్కి వచ్చే లోపల ఆ యొక్క ఈయన చెప్పిన పాయింట్ అప్లికబుల్ అవ్వదు ఇక్కడ. ఏంటి చెప్పాడు ఇక్కడ? డాల్టన్ అటామిక్ థియరీ said to be the all atoms of the element have exactly same mass అంటున్నాడు. కానీ whereas in the case of isotopes of carbon or isotopes of hydrogen తీసుకుంటే 1H1 1H2 1H3 here also mass is different కానీ ఇక్కడ సేమ్ అంటున్నాడు. కానీ దీనికి మాత్రం అప్లికబుల్ అవ్వదు ఐసోటోప్స్కి. సో అందుకని ఇది ఒక డ్రాబ్యాక్. ఓకేనా చిల్డ్రన్, వింటున్నారా? everyone understand the class, understand the concept. So drawbacks, Dalton's atomic theory, drawbacks. Let's go to the next point. So Dalton's atomic theory, the atoms of different elements have different mass number. That was explained by Dalton. ఓకేనా, డాల్టన్ ఏం చెప్పాడు? atoms of different elements have different mass and different properties అని చెప్పాడు. కానీ ఐసోబార్స్కి వచ్చే లోపల ఐసోబార్స్ తీసుకుంటారు. ఐసోబార్స్, వాట్ ఆర్ ఐసోబార్స్? atoms of different elements. C614 nitrogen 714. In this case these are isobars. Isobar means what? Different elements have different atomic number and mass number is same. Mass number same, but atomic numbers are different, mass numbers are same. That is called as isobars. Atoms of different elements have different atomic numbers but mass number is same. Mass is same here, but here what is saying? Dalton atomic theory, the atoms of different elements have different mass, but here mass is same. In the case of isobar C614 N714. So here atoms of different elements have different mass according to the Dalton, but here in the case of isobar atoms of different elements have same mass number. So that's why this is drawback. Atoms of different elements have same mass number, but this Dalton's theory is not applicable for isobar case because here atoms of different elements have different atomic numbers, same mass number. Mass number is same, but here atoms of different elements have different mass. So this is about the drawbacks of Dalton's atomic theory. So today I explained about introduction part of atomic structure and also explained about Dalton's atomic theory and drawbacks. So children, everyone should prepare about this Dalton atomic theory and introduction also and drawbacks also. Everyone should practice this concept. Tomorrow I will ask about this concept, Dalton's atomic theory, drawbacks also I will ask. Everyone should practice and remember. Okay na? Thank you children. Have a nice day.